Hey guys, so 11.2, another counting technique, another way that we can add things up. So this is different from the fundamental counting principle, where the fundamental counting principle is grabbing different groups of items like shirts, pants, shoes, or appetizers, main course, drinks, beverages. Okay, permutations is all about ordered arrangement of items. Okay, so right here you got the definition of permutations, and it's going to deal with one group only. So it's going to be talking about like maybe we just want to do something with main courses or things like that. Permutations, or kind of another example, like say we have a group of people and we want to elect someone out of them. So you're only going to be dealing with one group of items, okay? Where again, fundamental counting principle, you're grabbing from different groups, shirts, pants, shoes. Where permutations, and the same thing will happen with combinations when we get to those, I'll talk about that again too. You're only grabbing from one group of items, like maybe just main courses, or maybe you're picking books, or maybe you're picking songs, things like that. So here we're talking about ordered arrangement of items, okay? So when we're going to talk about an ordered arrangement of items that occur, permutations happen when no item is used more than once, so you can't select it again after you select it already. And then the order of the arrangements makes a difference. The order of the arrangements make a difference. I'll give you some examples. Like passwords. Order of the letters and numbers and symbols makes a difference. Okay? If you don't put them in the correct order, you are not getting into whatever you're trying to plug the input, the password into, because the order of everything matters. Okay? Same thing with locks. If you have to put numbers into a lock to unlock things, like on padlocks and stuff like that, the order of those numbers matter. Elections, like when you are electing a president, vice president, secretary, treasurer, the order matters. Reason why the order matters is because depending on who you put into office as the president, they have their own way of running things as if you put someone else into office. Imagine, again, go back to that 2016 election. We already know how Trump runs the presidency, but now imagine what would have happened if we put Hillary in as president. Again, things would have turned out differently. Good or bad, who knows? Okay? But when you're dealing with presidents, vice presidents, secretary, and treasurers, the order matters. Okay? Because just as I said, whoever you put in, the president, vice president, secretary, treasurer, they're going to run things the way they know how to run. Same thing if you are in a race. Order matters. Those that come in first place, second place, third place, order matters. Because when you come in first place, you're like, oh, here's $1 million. Okay? Because you won the race. Second place, oh, here's your $500. Third place, here's a ribbon, thanks for playing. Okay? Order matters in races when you're talking about first place, second place, third place. Because sometimes, if you're doing a preliminary race, you want to be in those top three because only the top three move on to the final race. Okay? So here with permutations, we're grabbing from one group. We can only grab one at a time. Once we grab it, it's done. So again, kind of going back to the presidency, you can't have someone be president and vice president at the same time. That just doesn't happen. You can't in a race, you can't have someone in first place and second place at the same time. That does not happen. Okay? So everyone can only be used once, and the order of that matters. Right down below here, you see that NPR that I talked about in 11.1. Excuse me. And again, in our calculator, because we're going to let the calculator do the dancing for us. Okay. In our calculator, remember that NPR I showed you in 11.1, but again, math, scroll all the way over to prob, and it's right there. It's number 2. Okay, NPR. We're going to use that a lot. And then here in a second, you're going to see the formula, which will let you use this little exclamation point, which is what we call a factorial. So 2 and 4 are things that we're going to use. Okay. So again, that was under math. Scroll all the way over to prob. And we're going to use NPR, which is number 2. And you might even use the factorial, which is number 4. Okay. So NPR. NPR stands for permutations of n things taken r at a time. So the n represents the total. The r represents what are we choosing. Okay, so like if I was talking about like the race a moment ago, like first, second, and third. So I have all the racers, that's n, and then the r would be who is my first, second, and third. So my r would be 3. Okay, so n represents the total, and r is talking about how many you're choosing. Okay, same thing like what I said a moment ago when we're talking about electing offices. I had president, vice president, treasurer, secretary. My N would be all the people running for the position, for those positions. My R would be 4 because I had 4 positions open: president, vice president, secretary, treasurer. Okay, so now that you know what N and R are, right down here, this is the formula right here that your calculator is running. This is the formula that your calculator is running. N factorial, all over, parenthesis, N minus R, parenthesis, factorial. Okay, so again, if you use the NPR in our calculator, you don't have to know this formula because that's what your calculator is running for you. You don't have to memorize this formula at all. Okay, but you can always run the formula for all these problems. All you got to do is plug in the N and the R. I'll show you on the first one, but after the first one, I will be doing nothing but the calculator to help me answer these. Okay, so let's talk about the exclamation mark. It means factorial. Okay, you see that right there. N factorial, N exclamation mark means N factorial. And it just means that all you're going to do is you're going to start at the number given, and you're going to multiply all the way down to the number 1. So you take N, take that number minus 1, take that number minus 2, keep multiplying all the way down to the end. Please know that 0 factorial is always equal to 1. 0 factorial is always equal to 1. And then right down here, again, I just gave you an example. All factorial just means is you're going to start at the number given, and you're going to multiply all the way down to 1. Okay, so if I had 7 factorial, it would look like this: 7 times 6 times 5 times 4 times 3 times 2 times 1. And in the end, you get 5,040. Okay, factorials get big really, really quickly. Okay, because you're just starting at the number and you're multiplying all the way down. Okay, you do not want to do factorials by hand. You don't really want to do these problems by hand, which is why I'm telling you to try and stay away from the formula. Again, for the first one, I will do the formula, okay, and show you what's going on. But after that, it's all calculator work. Let the calculator do the dancing for you. Okay, so let's take a look at an example. It says you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers. Oh, see right there, officers. I already kind of talked about this. A CEO, an operating manager, and a treasurer. And how many ways can those offices be filled? So let's talk about in terms of NPR. So N, how many people are there? And if you said 19, you're off just by a little bit. Remember, if you read that first piece, it says you and 19 of your friends. So technically, your N is really 20 because you are a part of this. Okay, so make sure again that you're reading carefully. And in the end, your R is going to be 3 because there are 3 offices: the CEO, the operating manager, and the treasurer. So if we're looking at this, our NPR looks like this: 20 P 3. So as I said, I'm going to show you the formula first. So if we did the formula is n factorial all over n minus r factorial. So our n factorial, our n is 20 all over 20 minus 3 factorial. So 20 minus 3 is 17 factorial. Now here's what's interesting. Again, remember that this is all multiplication. So the top up here looks like 20 times 19 times 18 times 17 times 16 times 15 times 14 times blah, 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 all the way down. The bottom, because it is 17, whoa, things moving around. Bottom looks like this: 17 times 16 times 15 times 14 times 13, blah, 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 blah. Well, if you notice, there are some things that are in common from top to bottom. Right up here, the 17 times the 16, 14, all the way down will actually cancel with the 17 times the 16, the 15, the 14, all the way down there. Because, you know, as what you in intermediate algebra, or if you've taken college algebra, this is what we call simplifying the fraction. These are common pieces from top to bottom, and we can take them out. So to get our answer, really all we have to do is take 20 times 19 times 18. And again, this is what your calculator is doing behind the scenes. So if we take 20 times 19 times 18, you get 6,840 different ways to fill offices. And that's it. All right, that's my one time. I'm going to show you by hand. Everything else, again, just let the calculator do the work. I know this was pretty easy with the canceling and only having the 3 numbers, but sometimes it's not just 3 numbers that you have of numbers left. So you need to make sure, you know, just in general, let the calculator help you. Please let the calculator help you. So again, how will we put this in the calculator? Well, here we go. So since we are doing NPR, again, I would hit math. I would scroll over to NPR, scroll down, and notice it opens 2 blanks. So I would hit 20, scroll over, hit 3, and then all you do is hit enter. Done. Let the calculator do the work for you. It's going to speed things up for you. It's going to, really help you out. Another way that you can do this, if just so you know, you can put in the first number, 20, then hit math, scroll over to your prob, scroll down to number 2. See there, it automatically put the 20 down below, and then you can hit your 3, and you're good. Okay? So there you go. That's how we run permutations. Again, I showed you the one time by hand. Now just let the calculator do the dancing for you. Okay? So now with permutations, there is one other piece that you have to be careful of, and that is, what if we have duplicates? And that's what this is about. So permutations continued. There's one little piece that you got to be careful of, and that is if we want to do a permutation of duplicate items. Duplicate items. Okay? So in duplicate items, this is what the formula looks like. It's not an NPR case. It is purely a fraction case. And so on top, you've got the n factorial, the total. And then down below, you've got p factorial, q factorial, r factorial, and it can keep going and going and going. That's why those dots are there. So all that those mean down below is those are the items that are duplicates. Okay? Those are the items that are duplicates. So like say that when you go to Boston Market, when you order your first side, you still have the same selection of sides for the next guy. That would for your next choice of slide. If you get two slides, if you get two choices of side, so that's what we would mean by duplicate, because the same set of choices I have here, the same set of choices I have for the next guy, it's a duplicate. Or like when we look at the problem for this, how they like to do this one is they like to rearrange words. Ooh, I forgot the R up here. Let's fix that. There we go. So how many distinct ways can the letters of the word Mississippi be rearranged? See, we have duplicate letters up there. Okay. So this one, unfortunately, you have to use that formula. And we're going to use fractions on our calculator to help us out. We're going to let the calculator do all the dancing. I do not do this by hand. I let the calculator do everything. So again, remember that formula is n factorial all over the p factorial, q factorial, r factorial, blah, 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 blah. Okay? So remember, n, still the total. Everything that's down below is just represents your duplicates. So if we look up here and we count things up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11 factorial. Then down below, we just start going through and we start working with our letters. Is there a duplicate of m? And there is not. So we don't worry about that. Is there a duplicate of I? Yes. I've got an I here, I've got an I there, I got an I there, I got an I there. So how many I's are there? There are 4. So that represents like that p factorial, see, because there are 4 I's. Okay? So next, I'll change up my color. I look at S. Do I have duplicates of S? Yeah. So how many S's do I have? I have a total of 4 of them. So I got another 4 factorial down here. Okay. And then I don't worry about everything. Oh, I come to a P. Do I have duplicates of P? Absolutely. How many P's do I have? I've got 2. So I have 2 factorial down there. So this, running this fraction in our calculator is going to tell us the distinct ways that we can rearrange this because order matters, okay? Taking duplicates into consideration. So all we're going to do is go to our calculator. We're going to put this fraction in and let the calculator do the dirty work, okay? So calculator, alpha, y equals, because I want a fraction. So 11, where do I go for factorial? Again, that's under math. Scroll all the way over to prob. Scroll down to the exclamation mark, hit enter. There's your top one. And then down below, all we're going to do is put in exactly what you saw over there. We have 2 4 factorial, 1 2 factorial. So 4 alpha, oh, sorry, not alpha, math. Scroll all the way over to prob. Scroll down to number 4. Then put another 4, math, prob, 4. And then 2, math, prob, whoops, too far, and then 4. And there you go. If I scroll to the side, that's exactly what it looked like in the Smart Notebook page I had a moment ago. All I got to do is hit enter. That's how many ways we can rearrange those letters into distinct patterns. 34,650. 34,650 different letter arrangements. And there you go. And that's all there is to permutations, okay? You're either dealing with an NPR situation where you got the total and you know how many you're picking, or you're dealing with a duplicate situation. Okay, so I've got 5 problems again, just like what we did a moment ago. Here they are. Okay, go ahead, pause the video, take a look at these, give them a shot. Okay, so let's start talking about this. Right up here, number 1. Again, in here, number 1, definitely a permutation. I want to talk about some of these other situations you might run into. Number 1, like when you're talking about a radio show, okay, and you are going to play records, okay, so in other words, songs is another word for records, okay. When you're playing songs, you know, as a radio jockey, you don't play all the good stuff right at the beginning and then all the crappy stuff at the end, because you're going to lose your audience halfway through. You know, as a disc jockey, you want to make sure that your audience stays with your show throughout the entirety of when you're there. Okay. And likewise, as a disc jockey, you want to put all your crappy stuff in the beginning, because no one will stay and listen if all the crappy stuff is in the beginning, all the good stuff is at the end. So that's why disc jockeys to play good, good, bad, bad, good, bad, good, good, good. You know, they vary it up with playing what's popular and maybe what is not quite as popular. The same thing happens when you are dealing with acts in a show. So say you're trying to put on a comedy show or a variety show, okay, or like a talent show, okay, you're going to vary your acts. You're not going to put all the popular acts at the beginning, okay? And the same thing is, you're not going to put all the musical acts and then the joke acts and then, you know, whatever acts you have, dancing acts left. You're going to do a variety of stuff because you want people to stay as long as possible for your show. So you might put like a musical group first and then another musical group, and then you might do comedy and then a dance and then, you know, a music group, you know, something along those lines. You're going to vary it up as it goes along. Because again, the order of your show matters. And the same thing when it comes to comedy acts. Okay. You don't put all of your funniest people in the beginning and then all your crappy people at the end, because again, just like the radio show, people are going to leave. You're going to do a variety. You might start with, you know, that's why you see some comedy shows, if you've ever been to one, they have like a little warm-up guy, a guy, you know, get you laughing and things like that. And then start bringing in some of their heavy hitters and things like that. You know, they build towards that. So if you're building an entire comedy show, you might have a warm-up guy. He's good, but not as good. Then you might have someone really funny, and then another really funny, and then maybe you back it off a little bit for another kind of warm-up guy, then another really funny guy, and then a warm-up guy. You know, you're going to vary the show because the order of your show matters. Okay, I'm saying all this because there are different examples out there where they talk about comedy acts, variety shows, things like that. And those are all permutations because the order of the show matters, just like for this disc jockey. Okay. So in here, a segment for a radio show, a disc jockey can play 7 records. If there are 11 to select from, how many ways can we do this? So this is definitely NPR. Okay, this is not a duplicate because we're not going to replay records. We're going to play them once. Okay, so how many records do I have total? I have 11. P, what's the R? I can only choose 7. Okay, so I had 11 records. I'm only going to choose 7. And now I just go to my calculator, let it do the dirty work. So I've got 11, math, scroll over, NPR, 7, enter. And that's how many different shows this disc jockey can have. 1,663,200 different shows. 1,663,200. Woo! Weird zero there. 0 programs. I am having a hard time writing. Different programs, let's say that. okay, where the order matters. All right, let's take a look at the next one. How distinguishable 6-letter words can be formed from the letters Hawaii? Oh, this should sound familiar, a lot like Mississippi. So this is one of those duplicate problems, because you can see you have duplicate A, you have a duplicate I. So how many letters do we have first? What is our N? Well, we got 1, 2, 3, 4, 5, 6. So we got 6 factorial on top. Down below, H doesn't duplicate, but the A does, and there are 2 A's, so that's 2 factorial. The W is not a duplicate. The I's are duplicates, and there are 2 of those, so that's another 2 factorial. So this is what we're going to put into our calculator as a fraction, 6 factorial over 2 factorial, 2 factorial. So calculator, alpha y equals 6 math prob factorials. And then 2 math prob, too far, and factorial, and then another math, too far. Oops. Added the wrong thing in. Math number 4. And there it is. Hit enter. 180 different ways we can rearrange Hawaii. 180 different words. Again, some of these words, when I say words, and that's why it's in quotations, though some of those words will not exist. It's just a different way that we can rearrange it. Okay? I'm not saying that there are different words, actual words there. All right. Next one. So question number 3 says a signal can be formed by running different colored flags up a pole, one above the other. Find the number of different signals consisting of 9 flags that can be made using 3 white, 3 red flags, and 3 blue flags. And what they're talking about here, and they use this a lot at the beaches, flag signaling to let people know and other lifeguards know the current conditions that are going on beach. So this is very applicable to us living here in Florida if you ever go to the beaches. And notice that these colors, if you didn't get onto this, there are duplicate colors. So this is one of those duplicate problems. And how do I know that? Because I have 3 whites, that's duplicate colored whites, and 3 reds and 3 blues. So when we run this, what is our N? Well, we can have 9 flags, or we have a total of 9 flags. And then down below is our duplicates. Well, there are 3 white duplicates, there are 3 red duplicates, there are 3 blue duplicates. So that's what we're going to go into our calculator and run. I'm going to kind of speed things up. I'm going to come up here and grab that last fraction. And all I'm going to do is go in and edit. We're going to change that 6 to a 9. We're going to change that to a 3. We're going to change that to a 3. And all I did to get this is I just scrolled up. You can see my blue cursor moving up. And I just hit enter on the fraction that I wanted to reuse. So scroll over. All I got to do is add one more 3 factorial. And you can do that anytime you want. You can always go back up and grab what you just did and fix it. So there is what we're working with. And there are 1,680 different ways we can signal with flags. Or you can say 1,680 flag combinations. Flag signals. There you go. See, nothing crazy here. So just let the calculator do the dancing. You just got to recognize what the situation you have is. Okay? Well, this one kind of seemed like you're doing all from different groups, but it's not really different groups. They're all flags, just so you know. So we're still choosing from one group. That wasn't a fundamental counting principle idea. All right, number 4. In a race with 6 automobiles, in which 6 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in? Again, this is all NPR because your N is 6. I got 6 race cars. P, how many am I picking? Well, in the end, I want to talk about the first 3 finishers. So first place, second place, third place. So all we got to do is go to our calculator and do 6P. So I can scroll up there and grab this 11P7, and all I got to do is just go back in here and change. So 6, scroll over, 3. So I have 120 different first place, second place, third place arrangements of those racers. Different top 3 finishers. All right, one more. So it says a club with 7 members is to choose 3 officers: president, vice president, and secretary/treasurer. So this position right here is all together. If you're the secretary, you are also the treasurer, just so you know. So that's not 2 positions. If each office is to be held by 1 person and no person can hold more than 1 office, how many ways can those offices be filled? Well, again, we just did this. So our N is 7, because that's how many people we have. Okay, P, and what are we choosing? 3 officers. Okay, so all we're going to do is go into our calculator and do 7P3. So I'm just going to come right back up, grab that P again, scroll over, just change that 6 to a 7, and now I'm good. Enter. So I got 210 ways we can select officers. 210 different officers. And that's it. That's 11.2.